I would like to start construction part, construction and fabrication part, and construction and fabrication processes, and to start from one of our biggest contractor, general contractor in Lithuania, PST, it's Panevezio Statybos Trestas, which decided to go on BIM way and to start work in BIM environment and to, let's say, work with contractors, subcontractors, which also can participate in BIM projects. So we name it first step using BIM in construction. PST, please welcome Rytis.
Hello everyone. My name is Rytis. I'm working as a BIM manager for PST, and today our topic is, I want to tell you how we are getting BIM into constructions. So let's start. Firstly, about PST. PST is a short name. The long name is Panevezio Statybos Trestas, but I think we will use PST. It's better. So the company was established in 1957. So it's quite old company with a lot of experience and good and big project accomplished. We have annual turnover of more than 90 million euros and more than 1,000 employees on board. So we are kind of a big company in Lithuania. Actually, we are the biggest general contractor in Lithuania. When I speak about PST, I speak about a whole group of company. Here you can see a list which company is within this PST group. I want to highlight a few of them. It's PST Nordic. It's freshly established company in Sweden. So we are stepping into Scandinavia market. And of course, PS Trestas is Latvian company. We are also working here in Latvia. PST can offer you a wide range of activities, starting with design. I'll talk about this later. Then also we have some companies which are manufacturers. For example, we have steel structures manufacturers called Metallomeistrai and wooden frame panel houses fabricator called Skydmedis. Of course, we offer all kinds of main construction works, from, I don't know, residential houses to towers, whatever, you name it, and also outdoor engineering. Here's a range of that project PST is involved in. As I said, from residential houses, then commercial buildings, public buildings, culture, heritage. By the way, PST accomplished one of the iconic project in Lithuania. It is in Vilnius, called the Palace of Great Dukes. So if you will be in Vilnius, please visit it. It's a very interesting object to visit. Also, we do a lot of infrastructure constructions and industrial projects. Also, big scale industrial projects. By the way, almost all biggest project of PST was nominated for Product of the Year nomination and won some gold medals. So it speaks for itself. Now about design. I want to talk about the design department PST projects. First of all, I'm working in it, so it's the main reason. And the second reason is that whole PST way to BIM started here from a design. So some facts about PST projects. Was established in 2001. Currently we have 35 specialists working, more than 35 now actually, and our annual turnover is more than 1.5 million euros, so quite enough. Also you can see our services, what we providing. I highlighted BIM. We at least trying to do what we can to implement BIM, to make all our projects one or other way BIM. Here you can see on the right side our software package. I think the main program is Tekla structures. Also we have ArchiCAD and DDS-CAD, and also some Autodesk products. So starting from the beginning, why did we choose to go for BIM? I see some smiles. But this BIM is not the BIM I'm talking about today. This BIM maybe is useful for construction site protection at night. Today I'm talking about building information modeling. So why did we choose to go for BIM? Yeah? First of all, we needed to find the way to improve our teamwork efficiency. In fact, our structural engineers was the pioneers to bring in the BIM. Yeah, they started to look for a program which is capable of multi-user module and for multi-material modeling. So the only solution was Tekla. From here, all credits goes to Tekla. I think we will get bigger discount next time we will purchase some licenses. So we started to work with Tekla, then we started to work with models from architectural part, and in this way, in working with models way, yeah, we get better distribution of the work between team members, better work coordination, and we eliminated some of mistakes, I hope so. So second reason why did we choose to go for BIM is we wanted to improve the quality of our projects, and working in BIM way, working with models leads to more detailed, more accurate, and more precise type of projects. So we achieved this. And third reason is better communication. Of course, it's more easy, more convenient way to work with models, to communicate through the model, than to work in old-fashioned way with 2D information. So visual information is always better for communication. Yes, so now about our first project. Here you can see some of them. It's very, very small number. I'll show you just projects, just integrated projects, which have, let's say, 2 or more disciplines combined in it. So, first our BIM project, first project with Tekla, was Silos Towers. It's for biofuels, meshed wood. Here we have 2 disciplines, is technology and structural part. We combined this together, and you can see result, how it looks like in reality, and how it looked before in our model. Yeah, next project is a police headquarters in Lithuania, in Klaipėda, our harbor city. Here also we have two disciplines. It's ventilation and air conditioning part, and structural part made with Tekla structures. By the way, ventilation and air conditioning part was made with DDS-CAD. So you see a result here. One more of our projects. This was done for Norway contractor. Here we have technology part and structural steel part. We have been detailing steel and sending drawings and fabrication files to our steel fabricator Metalomeistrai. I mentioned it before. Yeah, NC files for plates, for plasma cutters. So we have partly connection to the workshop, let's say. And one more interesting thing about this project, that there in Norway, they didn't use any general arrangement drawings or assembly drawings because they did everything, they assembled all steel using only model and Tekla BIM site. So it's quite good achievement, and people on site were very happy about that, as far as I know. Yeah, so keeping next, I want to talk more about this project. In this project, we combined all parts in one model. Here we have everything modeled and combined in one single model, and this model is used in design coordination and in construction site, like daily basis. So this project is called Joint Center for Life Sciences. It will be a part of Vilnius University when it will be finished next spring. Some facts about the project: it's 5-floor building, area more than 24,000 square meters, volume of course, and I want to highlight one number: it's laboratories. You see, almost a half of the whole building is dedicated for laboratories. Why I highlight this number? We have half of this building dedicated for laboratories. This leads to very difficult MEP part. Very difficult, because laboratories need special treatment for air, for microclimate. So for this project, in our way of thinking, we decided that the only solution is to go for BIM. In other words, virtual design and constructions. Yeah, so here I showed our workflow of working with BIM. We had a lot of subcontractors here on this project, and we established a BIM server on which every part updated their own parts and was getting an updated information from other parts. Also, we created an access for our guys on construction site. they also have access and also using these models for visual information and for work coordination. I'll talk about this later. And one more interesting fact about the early stages of the design of this project, that we tried to use Smartboard for design coordination. If anyone don't know Smartboard, it's like 2 meters wide iPad hanging on the wall. So it was kind of fun way for using it. Yeah, so about the models. Architectural model was created with AutoCAD Architectural by our subcontractors. It's kind of good model for working, because we used this architectural model for quantity takeoffs, some quantity takeoffs. For example, we count windows, doors of particular type, or for example, we needed to calculate area of the walls and distribute this area into some segments and tell our subcontractors how many square meters they should, let's say, build on site. It's for controlling them. So we did some takeoffs from this model. Then structural model. All credits goes to PST projects. We designed it, detailed it, to every single detail is in it. And also one interesting fact about this structural model, we worked together with Markučiai. I don't know if you know it. It's biggest precast concrete elements manufacturer in Lithuania. We worked together with Markučiai design department called Concretus Designers, and they were reinforcing all precast elements. It was kind of, we did all the geometry, for example, for precast wall, let's say. We put all the embeds, all connections, and simultaneously in the same model, Concretus Designers was making reinforcement, was making workshop drawings for them, sending to the workshop and delivering production on site. So in this way of working, we eliminated the overlap between two design teams. So we saved money and time. In other words, we have direct link to manufacture. This is good. And next, about MEP models. It was made with variety of programs. You can see up DDS-CAD, MagiCAD, Revit MEP, AutoCAD MEP, and we combined it in the one single model. We used that models for some clash detections, for visual information, for coordination. And the great tool for model reviews, especially on this project, was Tekla BIM site, free product. We used it for communication, coordination of works, especially at early stages of the design and in construction site. It's a very useful tool on site because you can use communication. You can do a communication, let's say, through a Dropbox directly in the model. Very good and useful tool. Yes, so how do we use BIM in constructions? First of all, it's for visual information and for coordination. In our biggest projects, we have like powerful workstations, which allows to open large BIM models, combined BIM models, to rotate them, pan them, zoom in, zoom out, whatever. Next, we use BIM for fabrication. As I mentioned before, we are working with Markučiai. We have a direct link through multi-user feature. Also, we used it for our cast-in-place concrete reinforcement. We sent models of cast-in-place concrete to our crew on site, and they used it for telling workers how the reinforcement should be laid out, how everything should be accomplished. So it was very useful, as far as I know. I was speaking with some site managers. They told that it's a very good way of working. Also, we used it for, and using continuously, because the project is going on. It will be finished next spring. So we are using it for installation of MEP, for installation coordination, let's say, to see how it will be installed, what should be installed, the sequence of installation. And of course, I mentioned before, we use it for some small-scale quantity takeoffs. Now, about benefits, what we see is what we get from BIM and what lessons did we learn. So, benefits. If you see if you read some articles about BIM, I think most likely you will find those benefits. But these benefits is what did we see from our point of view, and it's real. So it's better communication. Communicating through the models, it's always better than to use 2D. I always say that. Less mistakes on site. It's kind of a relative thing, but in design phase, we found some clashes. We found some things that went wrong on design phase, and we remodeled that, redone that, and so this leads to less mistakes on site. Or, of course, quicker work. Working with models also, it's more quicker than to take a bunch of 2D drawings and try to find something that someone did, someone drawn. So it's definitely quicker work. And working with BIM allows you to get information at any time you need it. All information that you need. So comparing, taking everything into account, this leads for better quality, faster project, and of course cheaper project. But also on this project we learned some lessons. The first one would be very good preparation, very good homework before the project starts. You need to make some rules how the BIM workflow will be established, what models, when should be, let's say, put into BIM server, when they should be updated, and such rules. I think Ernestas can tell more about this. Next lesson, Ernestas also mentioned about this, is that you need to find software with correct IFC import-export functionality. And this leads to BIM subcontractors which can do that, which can accomplish the model and work with other models. And last but not the least, you have to make very strict rules for models and for modeling, because everything should be exported, modeled as it should be. The column should be column, let's say, the beam should be beam, and such rules, because it's very important, let's say, regarding for quantity takeoffs and such kind of things. So I think we will learn our lessons, maybe you also. And now about our future plans. First of all, we want to make our Tekla model integration with measuring devices, direct, let's say, integration with, for example, Trimble devices. Wait, sorry. Yeah, we want to improve our quality of constructions and to have as-built models. Also, next, model-based planning and scheduling. We want to link our models to time, yeah, to get automatic schedules, and maybe next step for whole planning of whole construction process, for example with Riga software. Yeah, and then model-based material orders and purchasing. We want to make automatic quantities takeoff and link them to our order templates, so that people on construction site can just by clicking few of the buttons order the materials or elements directly in more automatic way, let's say. And of course, we would like to integrate price calculation into our BIM process. I think it's a very good feature to calculate price from the model, and in fact we have very good conditions for that, because we have a whole chain of processes in PST from design to manufacturing and construction site, so we can test this to work correctly. And I think we will do this, maybe not next year, but 2 years, in 2 years. Yeah, so that's the end of my presentation. Also, I would like to show you a live demo of the model if we have some time. Yes. Yeah. So maybe any questions for now?
I have one question. 1 2 1 2. You said that all these MEP different parts were drawn with the different software systems, yes, like ArchiCAD, Revit, and others. So what challenges did you have when you had to integrate all these models from different subcontractors and different software to one model? So can you talk more about that?
Actually, we had some issues about MagiCAD. DDS-CAD, Revit MEP, even AutoCAD MEP, but yeah, it was quite good. But talking about MagiCAD, our subcontractors, which was working with MagiCAD, could not import. Firstly, they couldn't import IFC from other parts, like architectural or structural, and other thing that they cannot export EFC file correctly. For example, they couldn't export the model which base point, start point is 0, 0, 0, like XYZ 0, 0, 0. Because, I don't know, MagiCAD have some issues with, with base points. I don't know. You have to move all the model like 2 meters in Y direction, 2 meters in Z in X direction, and so on. And we didn't get any information on elements from MagiCAD.
As I remember, because I spoke with your subcontractors, the reason why they was working in that way, because they don't found another way for calculation. So because some pipes goes out of zero or out of the line, so they moving the model, making calculation, and then manually putting back something like that. And I also remember Rytis that files from some parts was so heavy.
Yeah, it was from AutoCAD MEP, I think. It's very heavy files because AutoCAD is not exporting IFC correctly, and it exports a lot of details but none of the information, and that files are very large too, and it's very hard to handle them in combined model.
We should maybe you not mention that all communication was through the IFC. All softwares had to produce IFC.
Yeah.
Did the Rytis answer your question? Okay.
No more questions? Sorry, can't hear you.
How you manage releases of versions of files? That EFC one time they send one EFC, next time another EFC. Each time this project is developing, and how did you manage this challenge? Versions of files.
We have some rules for updating IFC files on the BIM server. We set the rule that everyone updates his part of IFC files like on Friday, every Friday. So, and checks for the updates on the Monday, checks for updates from other parts and do some coordination and changes. So it was weekly update, if I understand correctly your question.
Did you work on version number 2, or maybe you use data? Data, some?
No, data was from Windows, let's say, because if you are working with BIM site and you put a newer IFC file in the BIM server, and open BIM site, it pops you like a button which shows that some parts of IFC files are updated. You pushed it, and those IFC files update.
For Rytis, can we continue? Would like to ask some questions? Yeah. So Katya, with 4 and 5D are coming.